Now I'm live. And the screen is not stuck. Things seem okay. And now we will just begin. 192.168.29.1, which is my default gateway, which means the IP address to which I send my requests if I want to access the internet. How would I know that my destination IP address belongs to the internet and not under the subnet that I am connected to? Because I have the IP address for the default gateway, which I get from the DHCP server, and I also have the subnet mask, which I also get from the DHCP server. And the other things that the DHCP server sends me is a DNS server and my own IP address. Yep, crazy. And IPv4 and IPv6 just mean two versions of the same protocol, the same IP protocol in two versions. And yes, what does stateful IPv6 mean? Let's check that out. What is stateful and stateless IPv6 DHCP? Stateful versus stateless IPv6. In IPv6, devices can obtain an IP address and configuration details either statefully or statelessly. That is through the DHCP server. These terms refer to how the IP address assignment and network configuration are managed. How the IP address assignment and network configuration are managed. Yep, okay. Which is just handled by the DHCP server. So, stateful or stateless are two modes of the DHCP server, it seems. First, stateless IPv6 address auto configuration Slack stateless IPv6 ad address auto configuration Slack. No central server required. Devices generate their own IPv6 addresses using the network prefix advertised by a router. Users router advertisements RA uses router advertisements RA. All right. Routers send ICMPv4 router advertisement RA message, which contains the network prefix. Devices generate their own IP. The host appends its interface identifier, derived from MAC or randomly generated, to the prefix to form a full IPv6 address. All right. So my device gets a prefix from the router, and then my device generates a number either based on the MAC or the MAC address. What is the MAC address? And C stands for chip and multimedia access chip, I guess. Uh, MAC address full form. Multimedia access chip, media access chip. Media access control is a unique identifier for NIC chips. Yep. Unique identifier for the device network interface controller. Yep. Media access control is MAC address. No tracking of assigned IPs. The router does not keep a record of which device has which IP. Common use cases used in home and enterprise networks where manual configuration is minimal. Stateful IPv6 configuration DHCP uses DHCP v6 uh-huh, server. Mhm. All right, and so in this case, there is a DHCP server, but a DHCP server would also be required in this because I need to know the prefix and the DNS server and the subnet mask and the default gateway. Uses DHCP v6 server similar to IPv4 DHCP server. A server assigns IPv6 address and maintains a database and issue table. It does not use like NAT table, network address translation table. Centralized control. The server tracks which IPs are assigned to which devices. More configuration options can provide additional information like DNS, NTP, or domain names. NTP, some protocol, NTP, uh, server full form, network time protocol. Network time protocol is a protocol designed to time synchronize a network of machines. NTP runs on user UDP, all right, user datagram protocol, which is in turn runs on IP. Yep, UDP is different from user database protocol. Is a datagram protocol is different from TCP, transmission control protocol. All right, and common use cases used in enterprise networks where administrators need control over IP assignment. Okay, comparison table. Slack means stateless IPv6 mm, auto accounting auto IPv6 address auto configuration, right? And this uses DHCP v6, full-fledged DHCP server. V6 requires a server. This does not require a server. This requires a server. That does not make sense. Yep, that because my device needs to know the subnet mask and stuff. Okay, the stateless cell AC doesn't uses a doesn't use a server. Then how does the device gets its configuration, like the DNS server, subnet mask, default gateway, and the IPv6 prefix? Great question. Even though it's stateless auto configuration, address auto configuration, Slack doesn't use a DHCP server, it still gets a necessary network configuration from a router advertisement. Yeah, that would make sense because RA, in case of RA, the router advertisement, uh, everything, every device connected to that who is listening to that router advertisement should get the same message, right? The same prefix and default gateway and the DHCP server, the DNS server, and yeah, and the subnet mask is same for all the devices who are listening to that router advertisement. How Slack works without a server. How Slack works without a server. Yep. A router on the network periodically sends IM, ICMP ICMPv6 router advertisement messages, or devices can request them by sending router solicitation. Solicitation is like asking for advice, if I remember correctly. Unsolicited, unsolicited advice. Solicit. Uh, yep, it got disconnected, and now it is connected, and now it is not connected. Now it is shit. It always gets messed up. Now it is fine. Solicited meaning. Yep. Uh, it is something that is asked for, I guess. Solicited to ask somebody for money, help, support, etc. Yep. And to ask something. Router solicitation messages. These RAs provide critical network information. Okay, these are not servers because typically what a server means is that they are listening on a specific port and they respond in a particular way. But RAs is router advertisement. They are not listening for anything. They are just sending out messages. That is cool. That is cool. Getting the IPv6 prefix. The array messages include a network prefix like this. This is that this thing contains 64 prefix 64 bits. Okay, if the prefix is 64 bits, 64 bits can be represent 4 bits can be represented by one hexadecimal value, and therefore you would need 16 hexadecimal values to represent this whole thing. And in here you have 4, and 3 will be like there will be one more which is 0, so it is not represented here, and then one more here, and then one more here. All right, so and the last two are just 0. Self the device self generates an address by appending an interface identifier, which is called ID, to this prefix in the post of this message, which is 64-bit long. IID can be derived from the MAC address U EUI64 or randomly generated for privacy extensions for privacy. Okay, example, if the router advertises this thing, device with IID this will form this as the IP address. All right, here I have four. Here I have four. This one contains nothing. Shit, that does not make this whole um take up 32 hexadecimal characters. Right, 4 hexadecimal characters can together be used to represent how many bits? 4 into 4 into 4. Wait, 4 hexadecimal characters can be used together to represent how many bits? Shit, I am actually stupid. Um, yeah, 16 bits. So 16, 16, and in total, I need to represent 128 bits, and one group can represent 16 of those bits. So in total, I need how many groups? 16 into 32, 64. Right, yep, one group can represent 32 to 64. Four, um, yeah, 4 groups to represent 64 and 8. Yes, 8 groups in total. I'm actually stupid. 1, 2, 3, 4, 5 here, 6 and 7. That is 7 groups. And that is 7 groups. And this one is okay because this contains whole 4 groups. I suppose in this there is a missing group or something. The same array message tells the device who the default gateway is. The array message has contains a flag like this, which specifies the default gateway subnet mask. No traditional subnet mask like in IPv4. Instead, IPv6 prefix length is used as the array. In the array, the prefix length determines the network portion. Okay, that makes sense. DNS server, only Slack. Slack stands for the end part is auto configuration. SL uh, shit. A is address and SL stateless IPv6 address auto configuration. Slack alone did not provide DNS. However, the RDNSS recursive DNS server option in RA messages allow the router to advertise DNS servers. All right. If recursive DNS server is not supported, a network can use stateless DHCP6. More on this below here. What is the configuration is needed? Hybrid plus Slack stateless. All right. This is a hybrid version. Slack alone doesn't provide NTP network time protocol, domain names, and extra settings. If a network needs additional configuration, stateless DHCP v6 can be used. Slack plus stateless DHCP v6 equals device gets an IP and default gateway via Slack, but queries a DHCP server for extra info, like DNS for extra info, like DNS. The array message includes the O flag and all right, that is enough. Yep. In here, in this, the prefix length is 64. So in total, 16 hexadecimal characters are required to represent the whole prefix. But here I see less. Good observation. IPv6 addresses are written in a compressed format to make them shorter and more readable. Let's break it down. Why does this look shorter? An IPv6 address is 128 bit long, represented by 8 groups of 4 hexadecimal characters. Each group is 16 bits. All right. Dash slash 64 prefix means the first 64 bits define the network, and the remaining 64 are for the host. Now let's expand this step by step, right? Everything else is zero. Expanded uncompressed, the full uncompressed address looks like this. The first 64 bits, these, yep, like I said, the last two are zero, represent the network prefix. The remaining 64 bits are available for the host to put in anything that the host wants. Why is it shorter? IPv6 compression rules. IPv6 allows compression this to shorten runs of these. Right. Okay, so if I want to represent this, that just means this is the first one, this is the second one, and then the rest is zero. Alright, since this means fill in the missing zeros, the actual value is still 128. Alright, so this thing is actually representing 128 bits. Okay, let me go up there and here. Alright, so this means just fill in the zeros in middle, and this is the last part. This is the starting part. Okay, that actually makes sense. What happens when a device joins a network? This in the middle again represents omitted zero blocks, not just that here are four zeros, four hexadecimal zero characters. It just means that represent fill in all the zeros which are required to make this a 128-bit length number. Right. And shit, my screen got stuck, but uh, that was just like 2 minutes ago, so I can fix it, and I saw it, so that is cool. Yep, make this full screen, fit to screen, and yep, I'm back. And right. Content filtering, home security, network, LAN routing, wireless area network. Yesterday I created a new access point AP, which was cool. I created an access point which is giving me another access to my Wi-Fi, which says private network, right? Which is cool. And my router is a computer with a very specific purpose, which is cool. And these different IPs usually use a single NIC, and that is cool. They usually use a single NIC. Yep, I have three IPs running, APs running, AP1 to AP1, AP4, and AP5. AP4 and 5 run on 5 gigahertz, which is cool. And then security. Let's see what is in the. But before that, yep, channel spacing and WPS. What are these? Channel spacing and WPS. WPS, WPS, WPS. Right. Yeah, let's see. What is WPS in home Wi-Fi routers? WPS Wi-Fi protected setup in home routers. WPS Wi-Fi protected setup is a feature in home Wi-Fi routers that simplifies the process of connecting devices to a wireless network without needing to manually enter Wi-Fi password. How WPS works? WPS allows devices to connect to a Wi-Fi network using one of the following methods. Push PBC, push button configuration. PVC, literally push button configuration. Press the WPS button on the router. Within 2 minutes, press the WPS button. Within 2 minutes, press the WPS button on the device or select WPS in device settings. Okay, the device which wants to connect to the router, I suppose. The router and the devices automatically exchange credentials and the device connects securely. So if I were to, should I do it on this? Let's see. This might, let's see. Join network settings. Yep, there should be a WPS option then. This is Wi-Fi address. I guess that is the map for my Wi-Fi. Private, low data mode, limit IP address tracking. Forget this network. Alright, nope, there doesn't seem to be a WPS option. Pin method. Enter every router with WPS has 8-digit pin printed on the router label. Okay. Enter this pin on the device to connect. The router verifies the pin and allows the device to join the network. NFC, near field communication. Alright, this is not non-fungible communication. This is near field communication, rarely used. Some routers support NFC for WPS, Wi-Fi protection protected setup. Wi-Fi protected setup in which, alright, WPS provides a option to connect to the router without manually entering Wi-Fi password. Okay, same routers. Some routers support NFCs, which is near field near field communication. Near field communication. NFC. Alright, which is also used in some cases to charge phone. Not like in every case, NFC is used to charge phone. Tap an NFC enabled device near the router to connect. Is WPS safe? While WPS makes connecting to Wi-Fi easier, it has various security flaws, especially with the PIN method. The 8-digit WPS PIN can be brute forced with a few hours due to design weakness. Once the PIN is cracked, an attacker 8-digit PIN WPS PIN. All right, and okay, that is right. In a few hours, isn't a few hours too long of a time? Let's see, an 8-digit pin.c stdio.h int main, and here I will print numbers. Yep, int n starting at 0 and 8 digit is not too long. Yeah, it can be represented using 32 bits. Right, so that should be cool. While n less than max max int, all right, int max, yep, int max c limits file is not found. C limits.h, all right, slash shit, uh, stdio limits.h, right. That is cool. While n is less than maximum, what do I want? I want to do, nope, only one thing would be enough. Printf %d and a space comma n plus plus. All right, that is all that I want. Client 8-digit dot c and a dot out. Let's see how long it takes to run. And I am already at one, two, 3, 4, 5, 6 digits. Let's see. Yep, I am at 7 digits at this point. Let's see how long it takes. It cannot take, yeah, it can actually take a few hours, I suppose. Yep, it can actually take a few hours because I am right now uh, at 7 digits, and yep, after this there will be the 8th digit, which is, yep, going to take some time. Yep, I can stop it, let it run in the background, doesn't matter. Is WP safe? Yep, nope, it can be brute forced. Once the pin is cracked, an attacker can access the network. Many routers have vulnerabilities in their WPS implementation. And disable WPS if possible, especially if you don't use it. Prefer using WPA or WPA2 or 3 security with strong passwords instead. Okay. Um, there are, all right, push the button is one way, and WPS pin is another way. All right, when connecting to the Wi-Fi using WPS, I can simply choose to enter the WPS pin. Yes, if WPS mode is enabled on the router. Right, let's see how would I know if, how would I pass in, how would I switch from entering password for the actual Wi-Fi. WPS show password requires WPA. All right, if there is a WPS option, only then I would get an option on my side to enter a WPA password. All right, let me change my this to WPS status. It is on shit, and WPS setup method says via PBC, and I might have to log in again. Yep, I have to log in again. It's been 3 minutes. hmm Network, wireless, and shit, what the heck am I even trying to do here? WPS setup method start, operation succeeded. So what does this mean? Initializing WPS session. All right, I have to initialize the Wi-Fi session, WPS session, only then can it happen. And yep, frames have not dropped. That is cool. Initializing WPS session, it is not initialized at this moment. Then I will forget this device. Yep, forget this network, and shit, where is it now? We'll go there and look for it and try to enter W. Yep, that was stupid. I midstream changed my Wi-Fi, which, yep, is actually stupid. And I think even after forgetting the network, and I got the password for the network because my phone knows the password for the network, and it's my phone sent the password to my laptop, and that is how it worked. Alright, so let me turn off the WPS session. Okay, it was already on. Click on PVC to start a new session. Alright, now I can move on to security, I guess. Channel spacing. Okay, what is channel spacing? Channel spacing means what is the frequency gap between adjacent channels? What is a channel in communication systems, such as Wi-Fi, radio, or cellular networks? It ensures that signals on different channels do not overlap too much, reducing interference and improving performance. Channel spacing in different systems. Wi-Fi 2.4 GHz and 5 GHz. 2.4 GHz has 20 MHz channel spacing. Okay, since a single router is connected to a lot of devices, therefore those devices get different channels to communicate with each other. All right, and the difference between those channels is 20 megahertz in 2.4 gigahertz and in 5 gigahertz. Wi-Fi can have channel spacing of 20 megahertz, 40, 80, or 160 megahertz spacing for higher speeds. For higher speeds. All right, can I change channel spacing for my 5G connection and see how much I can take it up? Okay, there is only configuration settings for 2.4 gigahertz. I guess this should also be fine. 40 megahertz for 2.4 gigahertz channel spacing. All right, and then Wi-Fi is this or radio communication typically uses 200 kilohertz channel spacing, and AM or amplitude modulation radio uses 10 kilohertz channel spacing in Europe and Asia. Cellular network. All right, like when I'm using my phone to call someone, can you use flexible channel spacing? Yeah, it is in megahertz, not a channel spacing. Important, reduces interference, prevents signal from overlapping too much, optimizes bandwidth, ensures efficient use of frequency spectrum. Yes, because I have a whole bandwidth over which I can communicate. So, each individual person gets a separate piece of the bandwidth. And theoretically speaking, so theoretically speaking, since the 2.4 GHz Wi-Fi connection is not a wait, this theoretically speaking part will should come next. Is not a single frequency frequency, but rather a range of frequencies. Then theoretically speaking, shit, then theoretically speaking, a device which has a channel at a higher frequency gets a faster connection since it uses a higher frequency to transfer for data. But yes, there is the NTP protocol, network time protocol. NTP, great thinking. And, theoretically, higher frequencies can carry more data, but in Wi-Fi, the channel frequency itself does not determine speed, but instead bandwidth, channel width plays a bigger role. Let's break it down. With higher frequency is not equal to higher speed. All right, in Wi-Fi, a Wi-Fi channel, example, this channel goes from 1 to 2.4 gigahertz is just the central frequency. All channels in 2.4 gigahertz use the same bandwidth. Bandwidth. Okay, the bandwidth is okay 20 megahertz or 40 megahertz. The actual data rate depends on channel width, modulation technique, interference, and signal strength. This means closing channel 11 at this instead of channel 1 at this won't make difference in speed since both still use 20 megahertz band. What actually makes Wi-Fi faster? Using 5 gigahertz or 6 gigahertz Wi-Fi, these bands support wider channels. Example, 80 megahertz, 16. All right, allowing more data per second. Higher modulation. Example, this modulation. Okay, using non-overlapping channels reduces frequencies and beamform and MIMO. Memory input, memory output. Multiple antennas send multiple data at does higher frequency mean even more speed. In 5 gigahertz versus this, gigahertz 5 is faster because it has a wider channel range. Okay, channel range depends, can change the speed. It has been more than 3 minutes. I will have to log in again. Yep, it has been more than 3 minutes. And what am I trying to do here? I'm trying to make my address global so that it is accessible through the internet. All right, we have completed 3 things: dashboard, status, and network. And now you are here. Default policy, always allow. And in IPv4, is my stream stuck? No. In IPv4, I have a rule to always allow inbound requests, which I added before. Right, action, always allow. Service, HTTP, schedule, no schedule, or no schedule is the only option. Source IP address, any. All right, and destination IP address, any, from any to any. All right, that makes sense, and that is enabled. Now IPv6 firewalls. In IPv6, I have two requests, two settings. One is enabled, one is disabled. The enabled one takes inbound requests, and over the HTTP protocol, it always allows, there is no schedule and source. They can come from anywhere and go to anywhere. So that makes it seem like there is no problem from the router side. The router is allowing the things. The router is allowing the request to pass through the HTTP part. And custom requests, custom services. What are these? Port range, start port 80, end port 80. That would mean HTTP. And port range or multiple ports. I don't know. Port range, start port, end port. Well, let me say port number 23 to port number 443 is for HTTPS, and 444, that is the port range. Use the TCP protocol, right, to communicate. That should be cool. And port forwarding, it only happens for IPv4, right? Internal port range, internal port action, always allow HTTP request from any source to this IP address. Port forwarding. And internal port type, single port, which is 80. How do I know my local address? Alright, it is still fucking going, and we are only at halfway through the 7 digits. Yeah, it will take some hours. Some hours. This took 15 minutes to go to. Yep, three. Wait, fucking hell, and the. Oh, yeah, yeah. Three and halfway through the 7 digit mark. Alright, in clear, and I was looking for my if config en0. En0 is the it specifies the interface, and grep inet. Should get inet 4, which is this. This is my local network. This is my address for IPv4 requests, which are inbound IPv4 requests to my thing. If there are any HTTP requests to my router, they will be forwarded to my IP address. Client access control. What the heck is that? That allow action allow. All right. Client access control. Client MAC address. These are all the devices that have ever connected to the Wi-Fi. All right. And what is client access control? What is client access control? Client access control refers to a feature in Wi-Fi routers, network, and servers that allow administrators to restrict or permit devices from connecting to the network. It helps improve security, bandwidth, and management types of MAC address filtering. All right. Parental control restricts internet access for certain devices. For children devices can block specific websites. All right. Client access control is what happens in college Wi-Fi's, right? Yep. How do I do something with it? Off, on, how do I change the settings for client access control? Like there is nothing. It just lists devices that have ever connected. Alright. Content filtering. Hmm. Content filtering is off. Blocked keywords. I can block some keywords. That is cool. So does that mean my router is reading the bytes that are coming to it? Alright, import blocked keywords and approved URLs. Some URLs that people can visit. Then I have VPN pass through, which is virtual private network. Alright, VPN. What is VPN? VPN pass-through. What is VPN? Virtual private network. A VPN is virtual private network is a technology that creates a secure encrypted connection between your device and the internet. It hides your IP address, encrypts your internet traffic, and allows you to access the web anonymously and securely. How does a VPN work? Your device connects to a VPN server located anywhere in the world. The VPN encrypts your internet traffic before sending it to the server. Encrypts your internet traffic before sending it to the server. The VPN server assigns you a new IP address and forwards your request to the internet. Websites and services see the VPN's IP, not your real IP. The encrypted response is sent back to your device through the VPN tunnel. The VPN tunnel, alright, like SSH tunneling. Why use a VPN? Privacy protection, security on public Wi-Fi. Bypass encrypts data to protect against hackers on open networks. Bypass geo restrictions. Avoid ISP throttling. ISP Internet Service Protocol throttling stops ISPs from slowing down your internet speed. Huh. Is that one of the I think when I use VPN, my internet speed slows down while using a VPN. Secure remote work allows employees to access company networks securely. Types of VPNs: remote access, site to site, self-hosted. users set up their own VPNs, example, WireGuard or OpenVPN, used by businesses to connect office networks securely site to site. Remote access used by individuals to access the internet securely, not VPN or Express VPN. VPN drawbacks, slower speeds, yep, due to encryption and rerouting. Not all VPNs are private. Some free VPNs log user data. Fucking hell. Logged by some services, example is streaming sites, banking apps. Would you like to help setting up your own VPN? Key VPN pass through. So when using a VPN, my request first goes to the VPN server and then to the site that I intend to visit. That means that the VPN program installed on my device has full unrestricted access to the NIC driver my my device. It can make sys calls and monitor monitor every sys call made to the OS that involves handling the handling that involves functionality from the NIC driver. Question mark. Let's see. Yes, that is correct. When you use a VPN, the VPN client software on your device interacts closely with the network interface controller driver and the operating system's network stack to route your traffic through the VPN tunnel. This means the VPN software has high level control over your network activity. Let's break down how a VPN interacts with your NIC and OS. Oh, all right. I would also like to set up my own VPN. That would be cool. But for that, I would need a remote server, and which I do not have, but I can have if I want to have. I can have a free remote server. Hmm. The VPN client installs a virtual network adapter TUN TAP device on Linux, Mac OS, or a similar virtual NIC on Windows. All right. This virtual adapter is used instead of your physical NIC for routing network traffic, intercepts and encrypts all network traffic. Any network request from your device, example, opening a website, is first intercepted by the VPN software. The VPN encrypts the request before sending it to the VPN server, makes system calls, syscalls to the OS. The VPN software interacts with network-related syscalls like send, receive, and connect. It also modifies routing tables, changes DNS settings, and enforces a kill switch, blocking internet access. If the VPN disconnects, monitors network traffic. Since all your traffic is routed through the VPN, the software can theoretically monitor every request before encryption. A malicious VPN could log or modify traffic before it is encrypted. Full network controls, system-wide privileges, potential logging and data collection, and fake and malicious VPN. How to use VPNs safely? Use a trusted VPN. Check on open source options, right? And avoid free VPNs. Use a kill switch. Ensure that your real IP isn't exposed if the VPN disconnects. Consider self-hosting a VPN, running your own VPN. Example: WireGuard on a VPS virtual private server eliminates third-party risks. Right. So, okay, that is what a VPN does. It encrypts all the outgoing requests before they actually go out. Does a VPN create a virtual NIC for rest of the programs on the computer to use, and it itself uses the actual NIC to connect to the internet. And if any program has to make a internet request, it just it makes the request to the virtual NIC, which the VPN software listens to, and then the VPN software encrypts the request and sends it to the VPN server through the actual NIC. Question mark. Yes, you have got the right idea. Let me take it down. How a VPN uses virtual and physical NICs. VPN creates a virtual NIC, virtual network interface controller. When you install and run a VPN on your device, it creates a virtual network interface like a TUN tap device on Linux, Mac, or a virtual adapter in Windows. This virtual NIC is a software-based network interface, and it exists as an abstraction between your operating system and the physical NIC, the actual hardware that connects to the internet. Programs interact with the virtual NIC. All programs on your computers, example web browsers, email clients that need to send network requests, will send them to the virtual NIC. The operating system sees the virtual NIC as the active. My bad. The operating system sees the virtual NIC as the active network interface and routes all traffic through it. Alright, so it is tricking even the operating system. The operating sees the virtual NIC as the active network interface and routes all the traffic through it. VPN software listens to the virtual NIC. The VPN software listens for network traffic on the virtual NIC. When a program sends a network request, example trying to visit a website, it first goes to the virtual NIC. The VPN client captures this traffic and encrypts it using protocols like OpenVPN, IPEv2, or WireGuard. VPN forwards the request to the VPN server through the actual NIC. Once the traffic is encrypted by the VPN software, it is forwarded over the physical NIC, the actual network adapter that connects to the internet, to the VPN server. The VPN server then decrypts the request and forwards it to the destination website or service. Example, a web server response travels back the same way. The response from the web server is from the website or service is sent back to the VPN server, which encrypts it. The encrypted response then travels over the physical NIC back to your VPN software. The VPN software decrypts the response and sends it back to the virtual NIC, where it is delivered to the requesting program. Summary of the flow. Yep. Yeah. Why use VIC? Separation of traffic, encryption, network redirection. That makes sense. Yep. Alright, we can pass through attack checks. I'll have to log in again, I suppose. And it seems like I am pretty much done with the router part of my goal. To make my IP globally accessible, I have done uh, put in a firewall thing and stuff. Smurf, ping of death, Fraggle, DNS amplification, respond to ping on WAN port. Oh, fucking hell, is this it? This will enable ping network. Fucking hell. Alright. WAN is wide area network, which is basically the internet. TCP sync packets on. Alright, in this Smurf, ping of death, fraggle, DNS amplification. What the heck is ping of death? Alright, what is Smurf? Smurf. What is a Smurf attack? A Smurf? Smurf. Uh, what is that blue cartoon? Smurfs film series. Yep, yep, blue cartoon. The Smurfs. Smurf attack is a type of distributed denial of services (DDoS), distributed denial of services that exploits vulnerabilities in the ICMP Internet Control Message Protocol, specifically using a technique called ICMP echo request, commonly known as a ping. Okay, ICMP echo request. Yes, yes, that makes sense. A ping is also, of course, a program. Yep, a ping is also a program which uses, I guess, under the hood, it implements sockets and stuff. How does a Smurf attack work? Spoofing the source IP. The attacker spoofs the IP address of the target, the victim. This means the attacker pretends to be the victim. The attacker pretends to be the victim by changing the from address in the packets. The by changing the from address from the packets. Broadcasting ICMP requests. The attacker sends an ICMP echo request ping to a network broadcast address. The broadcast address sends the packet to all the devices on the network. These ICMP requests are sent to multiple devices on the network, but they appear to come from the victim's IP. Okay. Amplification. When devices on the network receive the broadcast ICMP echo ping request, they respond with ICMP echo replies. Since the response is much larger than the request, the attack is amplified. For example, a small 64-byte ICM request can trigger a response of 1,000 or more bytes, flooding the target. As a result, oh, that makes sense. That actually makes sense. And this is called spoofing, Smurf. All right, a kind of DDoS attack in which that makes sense. As a request, the victim's system gets overwhelmed with huge amount of ICMP echo replies. This leads to a denial of service because the victim's network or device becomes flooded with traffic it cannot handle. Why is it called a Smurf attack? The name Smurf comes from an old exploit tool named Smurf, which was used to automate this type of attack. The term also references the amplification effect. When the attack, when the small attack packet grows larger as they propagate, impact of Smurf attack. Denial of services (DOS). The primary effect is the target system or network becomes overwhelmed with traffic, rendering it unavailable to legitimate users. Network congestion. If the attacker uses device on a large network for amplification on a large network for amplification, the attacker can use significant network congestion, preventing a small attack. Disable IP directed broadcast on routers. Disabling IP-directed broadcasts can help prevent these attacks from propagating. Can help these attacks from propagating. Filtering ICMP traffic. Network administrators can configure firewalls or routers to filter or block ICMP echo requests from external sources. Spoofing detection. Modern routers can detect and block IP spoofing attempts to prevent attacker from impersonating the victim's IP. Alright, IP spoofing is randomly sending out a request and finding the IP of the person. How do you do IP spoofing? IP spoofing. The attacker spoofs the IP address of the target, the victim. This means the attacker pretends to be the victim. Alright, spoofing means changing the from in a packet. Spoofing detection. Modern routers can detect and block spoof proving attempts to prevent attacker from impersonating the victims. Alright, and this does not happen over the internet. This happens in a local area network LAN using anti-DDoS solutions. Solutions like rate limiting, traffic analysis, and intrusion detection systems (IDS) can detect and migrate these types of attacks. All right. Then I have ping of death. So what does Smurf means? Smurf attack means when I am connected to a local area network and I know the IP for a specific device and I want to mess that up, I send a ping request, which is ICMP request to all the devices in that network, pretending to be the victim. How do I pretend to be the victim? By changing the from part of my address of my outgoing address. And when I do that, all the devices in the network get that ping request, and when they respond, they send the response to the actual victim, and then the victim's device gets congested with all of these requests, and it is a DDoS attack. And what is ping of death? All right, it is also a DDoS attack. DOS attack that exploits vulnerabilities in the way systems handle IM ping echo request ping packets. It involves sending malformed or oversized ping packets to a target system, causing it to crash, freeze, or right ping of death. How does the ping of death work? ICMP echo request. Normally, the ping command sends a small ICMP request echo request packets to test network connectivity. These packets typically have a maximum size of 64 bits, exploiting the packet limit size limit. In a ping of death, the attacker sends ICMP echo requests that are larger than allowed size, normally larger than 65,000 bytes, which is just 65 KB, the maximum size allowed by the IP protocol. Fragmented packets. The oversized packet is often fragmented into smaller pieces before being transmitted. The attacker sends multiple fragments that, when reassembled at the target system, form a single oversized packet. System vulnerabilities. Many older systems and devices fail to properly handle these oversized or malformed packets. Upon reassembly of the fragments, the system may try to process the oversized packet, leading to memory corruption, crashes, or freezes. Denial of service. The result of a successful ping of death attack is typically a system crash or reboot, rendering the victim's machine unavailable or unstable. Historical context. Early vulnerability. The ping of death attack was a major issue in the late 1990s when many older operating systems, example Windows 95 or NT, were vulnerable to this attack. Modern systems have been patched to handle large or fragmented ICMP packets properly, making this attack mostly obsolete today. Impact of ping of death attack. Crashes, reboots, denial of services, preventing ping of death. System patches. Yep, patches to the modern OS and firewall protection. Configure firewall to block or limit ICMP traffic or ping requests, especially from untrusted sources. Rate limiting. Rate limiting ICMP request can help prevent mass ping requests from overwhelming the network or the system or network. IDS, IPS, intrusion detection prevention systems. Use intrusion detection IDS or intrusion prevention systems IPS to detect and block attempts to exploit ping of death or similar attacks. Alright, ping of death when I send a single packet, but that is pretty large, very large packet. Let me make this dark mode, which is like much cooler. Yep, dark mode, and then I have Fraggle. Alright, what is Fraggle? Is it Fragile attack, another type of DOS attack that is similar to the Smurf attack, but instead of using ICMP packets, it exploits the UDP, user datagram protocol, particularly by using UDP packets to a broadcast address of a network. It is often associated with amplification attacks, where the volume of the attack is increased significantly by the network devices that receive it. How does a Fragile attack work? Spoofing the target IP. Okay, spoofing means pretending to be someone else. Like in Smurf attack, the attacker spoofs the IP's victim address as the source IP. This means that the victim appears to be one sending out requests, sending UDP packets to a broadcast address. The attacker sends UDP packets to the broadcast address of a network. This means that the packet will be delivered to all the devices on that network instead of just one device, targeting a specific port. The attacker often targets a specific UDP port, commonly port 7 echo or port 19 charging, which are services that, when contacted, send a response back to the source IP address. These services typically echo the received data or generate a stream of data to the requester. All right. Amplification. The response from each device on the network after receiving the UDP packet is usually much larger than the original request. This is the amplification effect. For example, a small 64 byte may trigger 1,000 byte or large response from the targeted UDP service, flooding the target. Since the UDP response is sent to the victim's IP due to IP spoofing, the victim's system is flooded with huge amounts of traffic. This leads to denial of services by overwhelming the target's network or device with extensive traffic. Difference between Fraggle and Smurf attacks. Yep. The key difference is that Fraggle use UDP and Smurf uses ICMP. Right, ICMP is ping and UDP is user datagram protocol. Both attacks are amplification based, where the attacker sends a request to a broadcast address, causing the victim to receive much larger response. Impact of Fraggle attack: denial of services, network congestion, and amplification. Preventing a Fraggle attack: disable unnecessary services, configure firewall, rate limiting, spoofing protection, intrusion detect prevention system. All right, and then I have DNS amplification. All right, which DNS amplification, not just response amplification. What is DNS amplification? What can it be? DNS amplification. What is DNS amplification? DNS amplification. Shit. DNS amplification is a type of denial of services, distributed denial of services attack that exploits domain name service to amplify the size of attack target. The attack involves sending DNS queries to an open DNS resolver with a spoofed IP address, the target's IP, causing the resolver to send a much larger response to the victim. The amplification factor can specifically DNS amplification increase the traffic sent to the target, overwhelming its network or server. How does a DNS amplification attack work? My bad, it's moving the target IP of sending DNS queries on to open resolvers. The attacker sends a DNS query to open DNS resolvers like Google, which is at 8.8.8.8. A DNS server that is configured to accept queries from any IP address, not just those within a local network. The DNS queries can request a large response, such as a DNS record for a domain with lot of associated data. Example, a domain with subdomains or a large text record. That is amplification, sending a small request and in return getting a much larger response. And that response does not come to the attacker, that goes to the IP of the victim because of IP spoofing. The DNS server processes the queries and sends the response to the victim's IP. Because of IP spoofing, the response is much larger than the original query sent by the attacker. For example, a 60-byte DNS can lead to a 20,000, 2,000 byte response. This is the amplification effect, which makes the attack much more potent. Flooding the target. The victim receives a large volume of DNS requests from OpenResolver, which overwhelms their network or device with much more data than the original request. The victim's system or network may become unresponsive or experience significant latency, leading to denial of services. Amplification factor, impact of DNS, denial of service, network congestion, resource exhaustion, and preventing DNS amplification attacks. How I can prevent, and that is cool. Right, DNS amplification and respond to ping on WAN port. Right, all of these except the DNS amplification happens on local network. Does my router by okay, all of these except the DNS amplif amplification happen on the LAN, and does my router respond to WAN ICMP by fault if I am using a public IP or through a local IP using NAT? Let's see. Yes, all that I mentioned ping out at figure typically happen within the LAN. And these are there to overwhelm a target within the local network or amplify traffic through public facing devices like DNS or router and cause denial of services. Router respond to WAN ICMP with public IP. When you are using a public IP on your router directly accessible from the internet, or private IP with NAT network address translation, the way your router handles IMCP internet control message protocol depends on the router's configuration. Public address direct access. ICMP response. If your router is assigned to a public IP and is directly connected to the WAN, it may respond to ICMP requests such as ping from the internet by default. This means that devices outside your local network could potentially send ICMP requests to your public IP, and your router may respond back with an ICMP reply, assuming no firewall or filtering rules are placed to block this. Security risk. This behavior can express your router and devices behind it to various type of network attacks. ICMP flooding with ping of death. I got spoofing. I got fraggle. Spoofing is when I'm using ICMP and wait, not spoofing. Smurf attack happens on local area network when I use spoofing and send out a request through with spoofing, and mm, this request is a broadcast request, and all the devices which receive this request, they send back a response to the victim's IP since I used spoofing. Private IP address with NAT home. Most home networks ICMP requests from WAN outside. If you are being a router behind a router with NAT ICMP request from the WAN outside the local area network won't typically reach your local machine directly. The NAT process will block incoming traffic from the outside unless you have a port forwarding or DMZ demilitarized zone configuration that exposes a specific service or device, which I have. I have port forwarding and I have brought down a firewall. ICMP response. Even if a device inside your network is pinged, the router would forward the response through NAT. But this only happens if the device made a request from the inside, like sending a ping. The router handles the mapping of the private IP to the public IP and vice versa of outbound traffic using the NAT table, network address translation, firewall configuration, default behavior, routers, and so many. Shit, I am so fucking sleepy right now. DDoS prevention, there is nothing for DDoS prevention in this, and I will have to relog in now. I am actually fucking sleepy. I only slept for like 5 hours yesterday. Yeah, I was reading about ancient history, web management, advanced DMS network. Go to network and see if there is anything that we need to make our bridge mode DMZ host and Z6. Okay, bridge network. What is bridge network? And yeah, what is a bridge network? A bridge network is a type of network setup that connects multiple network segments, allowing them to communicate as if they are part of the same physical network. It essentially bridges different networks together and enabling seamless communication between devices across different networks. All right, physical bridge, virtual bridge network, and virtualization. Yeah. Right, now I want to make, I think from the router side, everything is okay. I have I my router, wait, if configure, yep, and the thing that it said before. Here, I'm using this, and here, okay, in this case, the whole IP address is given to me by the router. That is cool. And in this, only 64 bits are given to me by the router, and the rest is determined by myself. Now, yep. What is the question? My router, yep, my router gives me both an IPv4 and an IPv IPv6, and for my device to be globally accessible, I have changed the firewall settings to allow HTTP requests to from any source destination to source to any source IP to any destination IP. Right. Yeah, that much is enough. For both IPv4 and IPv6, and I also have enabled port forwarding to my local machine for HTTP requests for TCP at port 8. Uh, is there is this enough from the router side? Is this configuration enough from the router side to make my IP globally accessible. Let's see. Been back energy from the router's perspective. It looks like you have done a good job setting up a basic configuration to make your device globally accessible. However, there are a few more factors to consider and ensure that your device is fully accessible over the internet. What you have done: firewall configuration and port forwarding. You have allowed IPv6 IP. You have allowed HTTP requests, that is port 80, from any source to any. All right. This effectively opens your router to allow incoming HTTP traffic from internet to reach your device. Port forwarding. You have configured port forwarding to forward incoming TCP traffic on port 80 to your local machine. This ensures that when the router receives HTTP requests, it knows where to send them to your local machine. Additional considerations: public IP address. Make sure your router's public IP address is actually reachable from the internet. If you are using IPv6 and your router has a public IPv6 address, it should be accessible if the firewall and port forwarding are correctly set up. For IPv4, ensure your public IP is not masked by NAT unless you are using port forwarding to handle the routing. Alright, public IP, make sure your router's public IP address is accessible. My router's public IP address. How do I get my default gateway? Um, alright, IPv6 configuration, internal device configuration. Ensure that your local machine, the one to which port 80 is forwarded, is properly configured to listen for incoming HTTP requests on port 80. The web server is running and listening on port 80. Routers IPv6 configuration. You mentioned configuring both IPv4 and IPv6. Make sure that your device is properly configured with an IPv6 address and the router is correctly forwarding IPv6 traffic to the internal machine. IPv6 can sometimes be tricky since some routers have specific settings to handle how incoming IPv6 is Slack. If you're using Slack for IPv6, the stateless address auto configuration, your router might automatically assign an IPv6 address to your device, but make sure the router IPv6 packet is correctly set up in your local network. ISP NAT routers consideration test is how can you see me? Right. That is a good, I guess that is a good way. Your IP. Alright, it already has my IP. Check port. Shit, this website is amazing. Can you see me? It is actually fucking amazing. Alright, error. I could not see your service on this port. Alright, I guess because my server is offline, I'll go to my CD projects, YouTube stuff, and slash server. It is listening on port 80. Let's check now. Check port. Fuck. But wait, the port is only listening for IPv6 addresses. IPv6 requests. So how do I change it to IPv4? Just remove the 6. Right, buffer. Right, and yep, in this, just remove the 6, and in here, just add any already use of undeclared add any struct in add all right, it has to be in add, not any add. Adder in adder. Alright, that is not correct. Originally it was in adder 6. This shit, that is not correct. What can it take in? It can take in adder, as in adder. Wait a minute.